Methanoic acid versus ethanoic acid. This is today's lesson. In this lesson, we are going to learn some differences between them. So, let's get started. Methanoic acid versus ethanoic acid. This is ethanoic acid. This is known as acetic acid as well. It contains carboxyl group and alkyl group. So, this is carboxyl group. And this is alkyl group. Alkyl group contains 3 alpha hydrogen atoms. Because of these alpha hydrogen atoms, acetic acid undergoes Hell-Vollard-Jellinsky reaction. Due to the presence of carboxyl group, acetic acid is a kind of organic acid. On the other hand, methanoic acid. Let us write another formula of methanoic acid. Methanoic acid, which contains aldehyde group, CHO, aldehyde group. Again, methanoic acid contains carboxyl group as well. Due to the presence of carboxyl group, methanoic acid is acidic in nature. Again, it has no alpha hydrogen atoms. That is why methanoic acid doesn't suffer Hell-Vollard-Jellinsky reaction. That is, methanoic acid doesn't undergo Hell-Vollard-Jellinsky reaction. Now, let us see some specific differences between them. Methanoic acid. Which is also known as formic acid. Here, ethanoic acid or acetic acid. First point is acidity. For methanoic acid, acid dissociation constant for methanoic acid is 1.8 times 10 to the power minus 4. On the other hand, acid dissociation constant for acetic acid is 1.8 times 10 to the power minus 5. It means acidity of methanoic acid is 10 times higher than ethanoic acid. Number 2, thermal stability. Methanoic acid decomposes on heating to carbon dioxide and water, but acetic acid doesn't decompose On heating, no reaction. Then point number 3, dehydration with concentrated sulfuric acid. Formic acid undergoes dehydration with concentrated sulfuric acid, and methanoic acid changes to carbon monoxide and water on heating in presence of concentrated sulfuric acid. But ethanoic acid doesn't undergo dehydration with concentrated sulfuric acid, that is no reaction. Then number 4, chlorine. Formic acid doesn't react with chlorine, no reaction, as it has no alpha hydrogen atom. But ethanoic acid undergoes reaction with chlorine to form alpha chloro ethanoic acid. HCl is formed as byproduct. This reaction is a kind of Hell-Bollard-Zielinski reaction. That is, methanoic acid doesn't undergo reaction with chlorine, but ethanoic acid undergoes Hell-Bollard-Zielinski reaction with chlorine. Now, point number 5, diamine silver hydroxide. Which is a kind of Tollens reagent. Methanoic acid that has aldehyde group. That is why it can reduce Tollens reagent to silver, which deposits as precipitate, that is silver mirror, and byproducts are carbon dioxide, ammonia, and water. The reaction is conducted by heating, but acetic acid, it has no aldehyde group. That is why it doesn't undergo any reaction with Tollens reagent, no reaction. Then point number 6, failing solution. Copper 2 hydroxide and sodium hydroxide, failing solution. Methanoic acid reduces failing solution to red precipitate of cuprous oxide. Byproducts are sodium carbonate and water, but ethanoic acid cannot reduce failing solution. That is no reaction. Differences between methanoic acid and ethanoic acid. Thanks for watching.